All right, today we introduced the four basic building blocks for working with rotational flow. Now, there are many other functions that could be used, but these four are particularly useful because they allow us to define flows that are that represent flow interacting with solid objects. I'm just going to divide the screen into four quadrants here and note the four flows. We have uniform flow, source sink, a vortex, and a doublet. Uniform flow, as the name sounds, uniform flow typically from left to right. Source sink is flow radiating from the origin for the case where it's a source. The arrows are reversed for the case of a sink. Vortex represents flow around the origin with higher velocities near the origin and lower velocities as you get further away. And finally, the doublet is superposition of a source and a sink, or two counter-rotating vortexes that creates a figure eight pattern that is then nested like so. Mathematically, we can find the velocity potential for each of these cases. For a uniform flow, phi is u0r cosine theta, where the magnitude of the flow is u0. The source sink is that phi is equal to m over 2 pi times the natural log of r. M is then the strength of the source, and it would be negative in the case of a sink. The vortex is that phi is equal to gamma, the strength of the vortex, divided by 2 pi times theta. So whereas in the case of the source sink as a function of r and the vortex it's a function of theta, that produces, in the case of the source sink, a velocity that's purely radial. In the case of the vortex, a velocity that's purely circumferential. And then finally, the doublet, phi is mu times cosine theta divided by r. Now, in each of these cases, there is a parameter that defines the strength and sign of the component. By varying those four components and adding them together, we can superpose these solutions to define new ones. So superposition is simply the addition of components where we vary the magnitudes of the coefficients.